By 2027, the Arctic could be completely ice-free. A new study warns that the Arctic could become completely ice-free within 3 years. This year, the minimum sea ice extent was only 1.65 million square miles, significantly below the 1979 to 1992 average of 2.65 million square miles. Using 300 computer simulations, scientists predicted that the first ice-free day in the Arctic is guaranteed to occur within 9 to 20 years, regardless of how humanity alters greenhouse gas emissions. However, 9 of the 300 simulations suggested that an ice-free day could occur as early as 3 years from now, irrespective of future human actions. While the disappearance of Arctic sea ice will lead to massive changes in the Earth's climate and weather patterns, it will not cause significant changes in sea levels. Unlike glaciers or ice sheets on land, Arctic sea ice is already in the ocean, meaning its melting does not contribute to rising sea levels. For the same reason, a glass full of ice and water does not overflow when the ice melts. Dr. Celine Hoos of the University of Gothenburg, the study's lead author, stated that the first ice-free day could have a significant impact on Earth's ecosystems and climate, altering weather patterns. Researchers warn that an ice-free Arctic could lead to extreme weather events, including cold snaps of 20 degrees in southern Italy or wildfires in Scandinavia. On such a day, the Arctic Ocean would absorb significantly more heat than usual, making it harder for sea ice to reform. This increases the likelihood of periods without ice lasting not just a day, but an entire month. Previous forecasts of the disappearance of Arctic sea ice have typically focused on the first ice-free month, defined as the first 30 days with an ice extent of less than 386,000 square miles. In October 2024, the Arctic sea ice extent reached the 4th lowest level ever recorded for the month. Scientists are concerned that future summer months could see days or even weeks where the ice extent falls below 386,000 square miles, marking the threshold for an ice-free period. What is sea ice? Sea ice is simply frozen ocean water. It forms, grows, and melts in the ocean. By contrast, icebergs, glaciers, ice sheets, and ice shelves form on land. Sea ice is estimated to cover about 7% of the Earth's surface and roughly 12% of the world's oceans. Most sea ice is found in the polar ice caps of the Arctic and Southern Oceans. These ice caps are subject to seasonal changes, and on shorter timescales, are influenced by wind, currents, and temperature fluctuations. The ice extent typically peaks in winter and then shrinks in summer. Although this year's minimum Arctic ice extent was not as low as in 2012, orange line, experts warn that sea ice appears to be recovering more slowly. The study showed that warm autumns, followed by mild Arctic winters, could melt enough sea ice to produce an ice-free day in just 3 years. While this could have significant climate impacts, the melting of sea ice will not cause major sea level rise since it is already floating in the ocean. The greater concern is that this allows the ocean to warm further, melting glaciers and ice sheets on land, which will contribute to rising sea levels. Over the past 3 decades, scientists have observed that the Arctic sea ice extent has been shrinking by 12% per decade. In 2024, the minimum sea ice extent in the Arctic was one of the lowest on record, ranking as the 4th lowest ever recorded in October. When we lose this white surface and are left with a dark ocean instead, the sun's energy remains with us, absorbed by the ocean, leading to even greater global warming. This means that as Arctic sea ice continues to disappear, the likelihood of temperatures remaining high enough to prevent ice from reforming increases. The consequences of this could be severe, as the loss of Arctic ice destabilizes global weather patterns. This cycle will inevitably lead to ice-free months in the Arctic by the 2030s.